Hi everyone. Today we're going to study recursive formula of an arithmetic sequence. Also, we're going to find the number of terms in a finite sequence. Let's begin with recursive formula. Some arithmetic sequences are defined in terms of the previous term using a recursive formula. The formula provides an algebraic rule for determining the terms of the sequence. A recursive formula allows us to find any term of an arithmetic sequence using a function of the preceding term. Each term is the sum of the previous term and the common difference. The formula will be like this. A sub n equals a sub n minus 1, this is the previous term, plus d, the common difference. And this a sub n is the general term. There is a condition here that the n, which is the number of terms, must be greater or equal to 2. Here are the steps to find recursive formula. Given an arithmetic sequence, write its recursive formula, and this is the recursive formula. The step 1 is subtract any term from the subsequent term to find the common difference. Step 2, state the initial term and substitute the common difference into the recursive formula for arithmetic sequences. Let us have an example. Write a recursive formula for the arithmetic sequences A and B. Let us begin with example A. We have negative 18 as the first term, negative 7 as the second term, 4 is the third term, 15 the fourth term, 26 is the fifth term, so on and so forth. And here is the recursive formula. The step 1 says we will subtract any term from the subsequent term to find the common difference. In other words, let us find the common difference. We can take any two consecutive terms and subtract them. We will get the common difference, which is D. We can take this 26 and 15, so that is D equals 26 minus 15 equals 11. This is the common difference. We can take the common difference if we say take 15 minus 4, that is also 11, or 4 minus negative 7, that is positive 11, or the negative 7 minus negative 18, still that is positive 11. So we are sure that the common difference is 11. Step 2 says, state the initial term and substitute the common difference into the recursive formula for arithmetic sequences. In other words, we will copy the recursive formula here, and then we will substitute the value of D that we got from step 1. So you see here, same a sub n is here, equals the a sub n minus 1 is copied, plus the D, and it is now changed into 11. So this is now our recursive formula. We will just copy this below this problem A. Let's now solve for problem B. -1 as the first term, +2 second term, 5 third term, and 8 as the fourth term, so on and so forth. So step 1 is we subtract any term from the subsequent term to find the common difference. We can take this 8 minus 5 to be our D, and the answer is 3. We can see also that if we subtract 5 minus 2, we will get positive 3, or 2 minus a -1 is also positive 3. So the D equals 3. Step 2 is we will write the formula of the recursive, and then we will just substitute the value for D. So here is the recursive formula, and for this D, we will just change this to number 3, which is the D that we solved from step 1. So this is now our answer. We'll just copy this below problem B. So we are done with our problems A and B. These are our final answers. Let's go to finding the number of terms in a finite sequence. Here are the steps in finding the number of terms. Given the first 3 terms and the last term of a finite arithmetic sequence, find the total number of terms using these 2 steps. Step 1. Find the common difference D. Step 2. Substitute the common difference, first term and the last term, into the general term formula. And it is here a sub n equals a sub 1 plus the quantity n minus 1 times D. Then solve for n, because this n here is the number of terms. Let us see example 1. Find the number of terms in the finite arithmetic sequence 8, 1, -6, and the last term is -41. So we know here that a sub 1 is 8, a sub 2 is 1, a sub 3 is -6, and the last term is a sub n. Step 1. Let us find the common difference D. Using our second term and the first term, so that is 1 minus 8, that is equal to -7. Just to be sure, we can also check this -6 minus 1. We will get also this -7. So we are sure that this is an arithmetic sequence with the common difference D as -7. Step 2. Substitute the common difference, first term and the last term, into this general term formula, then solve for n. A sub n is the last term, that is -41, and this a sub 1 is the first term, that is 8. So we have here -41 equals 8 plus the quantity n minus 1, we will just copy, times the D, which is the common difference that we got from step 1, so -7. Then we will simplify from here. First, this -7 we will distribute to the terms of n and -1. So this -7 times n will be -7n. -7 times -1 is positive 7. We will just copy this number 8 and this negative 41 here. And then this number 8 and number 7 we will combine together. That is 8 plus 7, which gives 15. So the negative 41 is still here, and the negative 7n is also copied. Let us solve for the n. First, this number 15 we will transpose on the left side. Of course, the sign must be changed. So we have negative 41, now minus 15 equals the negative 7n. Combining these two numbers here, we will get negative 56 equals negative 7n. For us to get the value of n, let us divide this equation by the coefficient of n, and it is negative 7. So this negative 56 divided by negative 7 is positive 8. And this negative 7n divided by negative 7 will be n. So we can write n equals 8. And this value here is the number of terms. We can say that there are 8 terms in the finite sequence. Just for us to have a quick check, since our n, or the number of terms, is small, we can try to write all the terms of this finite sequence. So the 8 is here, also 1 and negative 6. Then the next term we can derive with the help of our common difference. So this negative 6 plus negative 7 is negative 13. Negative 13 plus negative 7 is negative 20. Negative 20 plus negative 7 is negative 27. This negative 27 plus negative 7 is negative 34. This negative 34 plus negative 7 is negative 41. And we stop, because that is now the last term. So let us count 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 terms in this finite sequence. So we are sure that this n equals 8 is correct. And this is our final answer. Let us have example 2. Find the number of terms in the finite arithmetic sequence. The first term is 6, second term 11, third term 16, and the last term is 56. Let us find the common difference. We can take this 11 minus 6, and that is 5. Just to be sure, we can also have 16 minus 11. That will give us 5 also. So D is equal to 5. Step 2, we will substitute the common difference, the first term and the last term respectively, into the general term formula. A sub n is the last term, that is 56. A sub 1 is the first term, and that is 6. So we have now here 56 equals 6 plus the quantity n minus 1 times the d. So we will use the value 5 that we got from step 1. Simplifying further, this number 5 we will multiply to n and to negative 1. So we have now 5 times n is 5n. 5 times negative 1 is negative 5. And then let us combine this 6 and the negative 5. So we have 1 plus 5n. We'll just copy the 56 down here. Simplifying further, let us transpose number 1 to the left side. The sign must be changed. So we have now 56 minus 1 equals 5n. Simplifying this value, we get 55 equals 5n. Let us solve for n. Divide this equation by the coefficient of n, which is 5. So this 55 divided by 5 will give 11. This 5n divided by 5 will give us n. So we can write n equals 11. So this is the number of terms for this finite arithmetic sequence. This is our final answer. I hope you learned something from this video. See you again next time.